Good morning, dear colleagues. I hope that you all can hear me well. So welcome to the Arctic Pavilion, the first ever Arctic Pavilion at Climate COPs. So I hope that we will all remember COP29, not only because of potential financial decisions, but as the first COP with a dedicated Arctic Pavilion. And today we gather here to have a discussion on a Northern Sea route, the potentially the global transportation route for the entire world. And we are discussing the environmental safety under the conditions of the very rapid change, climate change in the Arctic. We all know that the Arctic is affected by climate change way much more than any other region of the world. And the rate of temperature is also much higher than in many other parts of the world. That's create some challenges and risks, but it's also create opportunities. And opportunities, for example, for shipping operations. That's actually opening the Arctic seas and Arctic Ocean for more intense shipping operations at the scale we never saw before. The Northern Sea route is not a new one. So it was used actually for centuries in one or another way by Russian traders, by Russian researchers, by international researchers, and most recently, way much more intensely by businesses. And this relates not only to climate change and opening for a longer period of time of the Arctic seas, but also significant increase in economic activities in the Arctic. And that's what we want to discuss today, the different aspects related to environmental safety of this new transport arteria. And can we start the first one? Yes. So here on the slide, we like to show you the Northern Sea route as it's defined in a Russian legislation. Sometimes you will see other pictures, and I'm pretty much sure that through presentations of our experts today, you will see different maps. And just like to be clear that when we are talking about Northern Sea route, we may speak about two options. One is so-called big Northern Sea route. Sometimes it may start somewhere in Rotterdam or other European ports, and it will end in Vladivostok or even some Chinese ports. But for operational purposes in the Russian Federation, the Northern Sea route is shown on this map. It's much shorter route in between of two major straits, just from Novaya Zemlya and to the Bering Strait. That is a real Northern Sea route. And you also can see the intensity of shipping operations during the last few years based on data coming from all ships operating along the Northern Sea route. You can see that it's not actually, we call it Northern Sea route, but it's not just only one route. It's a diversity of options for traffic corridors, depending on ice conditions, depending on type of vessels, depending on type of operations. So that's what we plan to discuss today. And who is planning to talk to us about different aspects of the Northern Sea route? The session is organized by the Moscow State University Marine Research Center, which is one of the key research institutions in Russia working on marine issues, in particular for the Arctic. My name is Alexander Shestakov, and I'm a chief expert for the Marine Research Center. And today with us, we have a good variety of experts who will speak on different aspects of data gathering, data processing. We have with us Halldor Johansson, director of the Arctic portal, based in Iceland, working with substantial amount of Arctic data. We have Alexey Skorina, head of Department for Strategic Development at Moscow State University Marine Research Center. And Alexey will talk to us regarding the new developments in terms of digital services, digital platforms, remote sensing, which is in particular of interest for the Arctic, as of course we all know that accessibility of this part of the world is extremely limited. So the remote sensing technique and digital techniques became in particular of importance. We also will have with us Paul Hoos, President Alaska Marine Exchange from USA. And Paul is a very important person for the operations in the Beaufort Sea and Bering Sea, as actually helping shipping operations to be safe. And he will be talking to us about online system which provide for the safe operations of shipping in the Arctic. Digital platforms, information, all are important, but very much coming from research. And of course, the data is generated by research in the Arctic, and we have with us Elena Gershelis, Executive Director, International Research Center for Ecology and Climate Change of one of the newest Russian universities, Sirius University on Science and Technology from Russia. And speaking of science, we have with us also our colleague from India. India, which is, for some people, sounds like not an Arctic state, but the country which is very actively doing research in the Arctic, have their own station on Svalbard, and do a lot of very important science work in the Arctic, as well as actually India has a Arctic strategy. So Professor Bijoy Nandan, Senior Professor, Dean of Faculty of Marine Sciences at Cochin University of Science and Technology, so will join us to talk on marine science, but also that will be a presentation which will bring us closer to the operations of and discussions at COP29. And I am very happy to see Vladimir Rybinin, who just joined us. Vladimir is currently an independent expert, but for a long period of time, Vladimir was actually running the International Oceanographic Commission, which is a part of UNESCO, and the institution very much responsible for international coordination of ocean science and producing a lot of very interesting products. For example, I will mention only one. They developed the most important and most well-known guidelines on marine spatial planning, which is definitely super important for providing a safe operations in the oceans and the Arctic in particular. And I would like to start with Vladimir saying a few words on the current developments in the ocean. I'm pretty much sure Vladimir also will talk to us about extremely important initiative. We are living, I think, on the 5th year of this initiative. That's a UN decade on ocean science. So Vladimir, floor is yours, and we will be very happy to hear from you actually as a starting point for marine and Arctic discussion.
Thank you so much. To be honest with you, I didn't expect that I was supposed to be speaking, but only listening. But at the same time, the questions are so close to what I've been doing, or we have been doing, including with Evgenia. So, you know, it's an easy question indeed. So, you know, the situation in the ocean is significantly changing indeed. Ocean could be characterized by one phrase, out of sight, out of mind, on many international fora. But you see there is an ocean pavilion in the United Nations Framework Convention on Climate Change, COP. Also, there is an ocean climate dialogue in the under the auspices of subsidiary body for scientific and technological advice of UNFCCC. So things are changing, you know, and in 2015, it all started for me because I was attending the flagship COP in Paris that resulted in the agreement. And for the first time, ocean was mentioned there. No, because, you know, there is a big difference between kind of being mentioned and, you know, being treated very seriously. So ocean, according to recent understanding, is able to basically lead ocean activities and also some, let's say, carbon-focused activities in the ocean would be able, without even marine carbon dioxide removal, able to reduce around 35% of the emissions that are needed to remain within 1.5 degree warming by the end of the century. You know, indeed, and it was impossible, I think, for us to change the situation because we understood that ocean was small, Intergovernmental Oceanographic Commission was small, and we needed something big to change the course of action. And three thoughts came together. The first thought was about sustainable development because it was adopted by United Nations General Assembly by all countries of the world in 2015 in September at the start of the assembly. Then the second thought was that sustainable development is really dependent on the ocean and also on the ocean sides. So two things. And the third thing was the decadal time scale, because according to what, and this we are in the Arctic Pavilion, you probably remember the International Polar Year 2007-2008. It was a remarkable campaign, but too short to achieve sustainable developments in the Arctic. We wanted to develop the Arctic observing system, but we didn't manage. There were some discoveries during IPY 2007-2008, but you know, what happened to polar research in the world was that previously the global volume of that research was of the order of $100 million per year. During the International Polar Year, the volume of that research increased almost twice to $1.5 billion per year. But after that, IPY, it dropped to $600 million per year. So, you know, the countries were not convinced and were a little bit exhausted. So we needed to something longer, more sustainable. So that was the idea of the decade, but we didn't expect that it would be United Nations decade. We had tough negotiations in United Nations General Assembly, and then we convinced them that if you proclaim it now, it was happened in 2017, they will have 3 years to engage the whole community of the world. So the difference of the decade with previous, I would say, projects, it is, despite it is a proposed and proclaimed activity by United Nations, it's a bottom-up activity. We co-design our activities, and this co-design and the partnership collaboration spirit actually changed the mode of oceanography progress in the world. We have 55 different decade programs, or 56, it's difficult to say now precisely. You know, each of them is equivalent to some extent to the projects that were considered flagship projects in oceanography in the future, including also program in the Arctic. You know, it was moved forward by Danish colleagues, but I think, you know, that this program can also benefit from wider cooperation in the world. So that is basically what is happening. We have a global framework, and then indeed this framework has to converge to something. And in my understanding, the best conclusion for the decade would be that if we move forward towards sustainable management of the ocean. Oceanography is a regional science, and there are a lot of regional activities, like you just mentioned. And because of that, I think if we make, if we succeed in converting the decade 56, 55 programs to a coherent value chain of oceanography that will be delivering on regional and global scale, that will be the success. This requires additional development, and this development started because now we are basically studying the results of the Ocean Vision 2030 process. And I think more can be done to basically convert all the work and dedicate into basically, I would say, a wheel of delivering information. You know, we conducted research on the global ocean observing system at the end of the first decade of the century, and we understood that it is possible to construct modern oceanography and oceanographic observations in a very meaningful way. So probably the same thing needs to be done with the ocean. That will be the start of the new ocean science policy interface. And I have to say that because we are sitting in the Arctic pavilion, this may also change the situation in the Arctic, because Arctic is really changing. You know, I have been working in the Arctic since already more than 35 years, excuse me. And, you know, the changes in the Arctic actually make it possible to also, first of all, increase cooperation, which is now completely, say, on two sides of the Arctic. And also, Arctic requires a very significant study because of the changes happening there, the changes in terms of climate, and the repercussion of those changes in terms of ocean management. And indeed, the prospects of using sea routes in the Arctic are fantastic. So that's, I think, we need to continue our work. And that's my basically short account of what was happening in oceanography and a little bit in the Arctic. Thank you so much for your attention.
Thank you, Vladimir. Thanks a lot for this introduction. And I think that will also give us a better opportunity to put the whole discussion at today's session in the context. So to continue, I will use a power of moderator, and we'll start the presentation on behalf of the Moscow State University Marine Research Center, talking about the Northern Sea route safety and what is done during last number of years by the Marine Research Center together with partners and very much with the support of Rosatom, as Rosatom is a official operator of the Northern Sea route in Russia. And Rosatom paid a significant amount of attention to the environmental safety of those operations. The title of the presentation is actually From Environmental Monitoring to Sustainable Shipping. And we try to say that, first of all, of course, environmental safety in marine realm, whether we are talking about shipping or any other kind of human activity in the ocean, is impossible without good knowledge of what's going on, what is the status of marine environment, marine biodiversity, but what also are the impacts. And in the Russian Federation, there is pretty significant legal basis to ensure that operations in the oceans, including shipping, are environmentally friendly and sustainable. So I'd like to stress only a few of them at the higher level. And that's, of course, the overall law, federal law related to the organization of operations on the Northern Sea route. We also work within the framework of the national strategy for the development of the Arctic for the next actually decade, as well as recently, only a couple of years ago, the government adopted the special plan to develop the Northern Sea route operation, very ambitious plan, which foresee very significant increase of shipping operations. All those documents, they contain part related to environmental safety, related to design of environmental monitoring system for the Northern Sea route to be actually fully in line not only with the national regulations established in Russia, but also very much using the best available international practices and international regulations First of all, of course, when we are talking about regulations coming from International Maritime Organization, IMO, but of course also very much guided by the law of the sea. And we know that law of the sea was developed through the system of additional conventions and protocols. All of them fully apply to the Arctic, and it's enough to say, or to name only one of them, actually the Polar Code, which very much regulates the operation in the Arctic. So during last 4 years, since 2021, and as I said, very much in support and initiated by Rosatom, the project was to develop the comprehensive environmental monitoring system for the Northern Sea route. I like to stress that while actually the task was to develop monitoring system for the Northern Sea route, in reality, many elements of the program basically can cover a way much wider area of the Arctic. And we do not pretend to say that it's a monitoring system for the Arctic, but to a great extent, it covers probably around 70% of the marine Arctic within the Russian territory and exclusive economic zone. So the work combines the field research because we definitely need to establish baseline and understand what will be the point to count potential impacts of shipping operations along the Northern Sea route. And we had 2 full seasons of those operations, as well as actually the whole season of operations, checking the status of, first of all, biodiversity, but also a number of abiotic components in the main ports of the Arctic. Based on this, we developed the approach, the plan, and the program for environmental monitoring, which was also provided to the Minister of Natural Resources and Environment with a view to be converted into state environmental monitoring program and to be actually the subsystem of the the national system of state environmental monitoring. The research during the period 21-23 was focused, and I said, on a number of abiotic components related to atmospheric research, of course, hydrology, ice conditions, but also pollution of water and bottom sediments, as well as actually all groups of organisms, starting from benthic and finishing with marine mammals. That was done using the research vessels, but also very much operations of vessels which belong to Rosatom to organize the en route observations, first of all, for marine birds, seabirds, but also for marine mammals. The results were compiled into comprehensive program for monitoring. You can see here the visual map showing the key monitoring stations. Again, if you think about almost 4,000 kilometers of the Northern Sea route, that's almost 80 stations. Stations of different types, because some of those stations were identified as stations to really show very significant level of impact, for example, in port areas. Some of them, and you can see some green stars, which supposed to be monitoring sites to show us the status of biodiversity, let's say as a reference points in areas which are not directly impacted by the Northern Sea route. Some of those polygons are, for example, the yellow stars. They're actually within the corridor of the Northern Sea route. So they're supposed to give us a better understanding of direct impacts of the shipping operations. And some polygons, mostly yellow squares, that's a stationary polygons, mostly coastal. which will provide an information on situation with, for example, bird colonies or concentrations of marine mammals. Very ambitious program. So 80 stations to be monitored on a regular basis. The program includes not only the main objects to be monitored, but also the description of methods for each monitoring object, as well as periodicity. And periodicity is, of course, a challenge because sometimes scientists, they like to do it 3-4 times a year, which probably is impossible if we are talking about the practical monitoring system for the Arctic at this scale. So based on this scheme and based on this approach, the more pragmatic way to establish monitoring system was developed, which we hope within the next few years will be actually operationalized as a state monitoring system for the Northern Sea route. So the technology is great, but sometimes it's not working. Can we ask colleague to help?
Dude, you gotta stay there.
Yeah, thanks a lot. Here, just a very short illustration that coming from monitoring research and identifying specific sets of data, we moved further to, first of all, develop some management tools. And here is an example of approaches to reduce impacts on marine mammals, working together with the shipper operators. We are discussing currently with the Directorate of the Northern Sea Route what can be done on the ground in terms of shipping operations to reduce impacts of marine mammals, and the information very much coming from the monitoring research. But also bearing in mind how far is most of those areas, how difficult to send physical expeditions. So we develop as a number of digital platforms, and Alexei will talk more on what is available today and what is the direction for development of those digital services, using very much the remote sensing technique. And the next step, how we see the next step. Fantastic to have data. We will have more presentations today on science, but we need to come to the ultimate goal. And the ultimate goal for us is to ensure, and Vladimir was talking about sustainability of operations in the Arctic. So we like to see sustainable shipping operations in the Arctic. How sustainable shipping operations in the Arctic will look like very much relates to what we are discussing in COP29, because definitely climate component is super important. But why we need to do that? We need to use opportunities with reduced sea ice and changing weather. Weather is not actually in the Arctic became way much more favorable for operations, maybe actually more difficult because less predictable now. But conditions of opening the Arctic for more activities definitely dictate the requirement for sustainability. The climate change requirements, we hear a lot at this conference of the parties, put more requirements for the shipping operators. Even if shipping operators altogether considered to be 3-4% of total emissions, still pretty high. And most discussions here, especially in the ocean pavilion, are actually towards a decrease and decarbonizing the shipping operations. How we understand the sustainable shipping? Of course, it's a part of sustainability approach. It's a part of the concept of sustainability in the world and sustainable development. So definitely includes all elements, environmental elements, but also social elements, finance, and of course, the sustainability of shipping operation is not focused on reducing or limiting shipping operations, but definitely ensures that the economic development, including shipping operation, is sustainable. So if you are talking specifically on the environmental component, and of course, as Marine Research Center, we are first of all engaged into environmental discussions. So we need to cover many elements, and not only climate change issues, but of course, wastes, of course, discharges. We also know that shipping is one of the key reasons for distribution of invasive alien species. We also know that we have collisions with marine mammals, and we need to reduce impacts on marine mammals, especially big marine mammals as whales, as actually they communicate with sounds. And the noise provided by shipping is very significant level of disturbance. So that's all need to be factored in when we discuss the principle of sustainable shipping. And our goal is to move forward and develop the sustainability guidelines for Arctic shipping, and in particular shipping along the Northern Sea route, using the available best international practices, using the best international initiatives, whether coming, for example, from IMO or coming from International Oceanographic Commission of UNESCO, or coming from actually some associations, like, for example, World Shipping Council or Sustainable Shipping Initiative, which are very important international initiatives. And of course, we never forget about the Arctic Council and its working groups, which are developing their guidance for operations and sustainability in the Arctic Ocean. And with that, I stop here. And I think that talking about, I hope we will have some time for potential questions at the end of the session, but now rather coming to our next speakers. Can we ask our colleague? So the next speaker is Halder Johansson, director of the Arctic Portal. Harald, are you online with us? Yes.
Hey, Alexander, yes, I'm here.
Welcome. And the Arctic Portal is a super important initiative, bringing a lot of Arctic data together. So, Halder, we are looking forward for your view on the Arctic shipping.
Yeah, thank you very much. And it's a pleasure to take part. I was actually at the COP last week and have been to some of the previous ones. Of course, as has been somewhat indicated, there's a lot of good discussions going on, but there's also a lot of echoing of what has been in the past. And we also know, as was mentioned by previous speakers, that the coherence and the let's say the stability of the work, especially in a global context, is not as it should be, in my opinion. And if we okay, let's see, wonders of technology now. Sorry, here. We just first consider what is it that we call the Arctic? Because I think that's one of the things that we often have different discussions on. Is it what is within the Arctic Circle, or is it, as this map shows, the different definitions of the Arctic Council and the different working groups? Of course, it is a region of great opportunities, but it's also, as mentioned by Alexander, a region of challenges and potential threats. And the phrase that is commonly being used now, what happens in the Arctic doesn't stay in the Arctic, I think is very true, because it is known now that the changes in the weather patterns of the globe are largely contributed to what's happening in the Arctic. So it is an area of great concern, but also opportunity. And it is believed that this region may hold as much as 30% of the unused resources of the world. So it is, of course, evident that transport routes will be used and need to be used, but we need to increase the knowledge as much as possible to do it in a safe way and respectable way, as Alexander has also been pointing out. We know also that apart from the northern sea route and northeast passage, as has also been referred to, with the connection to Europe and Asia potentially, it's also potential trans-Arctic shipping route and of course also the Canadian path, the Northwest Passage. So it's very important that all this work is looked at in a coherent and in a global context, because even though we know that this is the line that's being used the most now, the other ones will follow. And we also need to look at it in a global context, because as Alexander also pointed out, and Vladimir before him, the shipping in the world is likely to increase, and we have concerns, geopolitical concerns, of course, also, and environmental concerns. So in my opinion, Arctic shipping needs to be looked at very carefully in a global context, because we know, of course, that the shipping through the Arctic is extremely limited compared to the Suez Canal. Suez Canal has some 20,000 plus transits, whereas the Arctic has been within the hundreds over the past years, and even less in the last couple of years. But we also know of the geopolitics happening and the political unrest in the Middle East. And as an important friend of mine in China has pointed out, yes, the interest of the Arctic is one, the resources, secondly, the transport routes, and thirdly, the security of transport. So the Arctic should be looked at in that context. And we should not forget, of course, also the opportunities that lie in the connection that goes east-west and also north-south. And then, of course, the inbound connections within Russia. So it has a very big and important role in a very global context. But we, of course, know that we have sea ice in the Arctic, and that's also been pointed out, and we need to monitor the changes in the sea ice. But we also know that the winter sea ice is getting thinner, so the opportunities for Arctic shipping are only increasing. But it all points to the same thing: we need to improve our knowledge. Arctic Council hasn't been mentioned yet, but Arctic Council, of course, is a very important venue for collaboration, and it has been quite dormant, as we all know, for the past 2 years, but hopefully we will see changes in that matter in the very near future that will increase the collaboration again, because there are important initiatives within the Arctic Council that should be concerned and considered in the context of the Northern Sea Route and environmental monitoring. So I hope that that collaboration will continue, but no matter what, the previous work of the Arctic Council is available and should be used as a platform. We also have, of course, some legislations again in an international context, like the IMO Polar Code and the search and rescue agreements of the Arctic Council that help in the matter of environmental safety. We also have quite a lot of work to base on the marine ecosystems definitions, and quite a lot of this data is available, and these are maps that have been generated by the Arctic portal based on this data. And my desire is to be able to as the system that Alexander pointed out, we can put these things together in a macro and micro context, so that we can zoom into the things properly. And this is the problem, of course. A lot of our information and data and our knowledge is fragmented, and we need to work on ways to connect it. So that's why I very much appreciate the work of the Marine Center and hope to expand it. We also know quite a lot about the different mammals and the different species in the Arctic. But we also know, as you can see from the map on the polar bear population, we're still lacking a lot of data and a lot of information to be able to really estimate and give guidelines. Because as also Alexander mentioned, guidelines are so important, and these guidelines need to take into account as much of the ecosystem as possible and the different aspects of the ecosystem. And whales have been mentioned, and we see from those maps that the Arctic shipping, of course, is going to affect them in some way or another. And then, of course, what happens on land is also important, because permafrost thawing is a big issue. And this will contribute to changes in the ocean. And what has not been mentioned yet is also the fisheries opportunities, because the smaller vessels related to fishing, they will increase in the Arctic. With less sea ice, there will be an increase in such shipping. And then, of course, another aspect is tourism, and small and medium ships and even bigger ships are going to be coming into the Arctic, which also increases the environmental and safety aspect of everything. So these are components that need to be contributed or has to be considered. And then, of course, linking of data. We are involved in a project now with SEON and University of Colorado, actually funded by NOAA on basically linking the knowledge of monitoring. Such initiatives, in my opinion, are so important, and because, as also been mentioned, I mean, there's one ocean in the world. We call it different names in different regions, but it's all the same water. So excuse my language. If I piss in the water in Iceland, it will end up in Australia at some point. So it's all interconnected, and we cannot consider something without linking it to the rest. So what are my conclusions in that aspect? Long-term monitoring is needed, and it has to be done in an international context. As pointed out before, there was a good kick when the International Polar Year was established, and I took an active part in all of that. But then it dwindled, and we have been involved in quite many projects over the years, but usually they are 4 to 5 years, and then nothing happens. We host the Global Terrestrial Network of Permafrost database, and it was established. Well, the work started in 2011-12. Then the principal funding ran out in 2016. We're still hosting it. We're still trying to maintain it. We're still having discussions with different partners on how to maintain it. But to be honest, not too much is happening. And that's a big concern to me. Is like, we talk a lot, but then actions are really required. And I've been involved in SEON for a long time, and we've had that same discussion. As you probably know, the SEON Secretariat was almost closed a couple of years ago because of lack of funding. And this is a concern to me, at least. And I think this is also what Alexander also pointed out. Of course, we need to have long-term funding. So the governments need to both individually and collectively have to work together. And we have to include diverse methods of data collection, both the complicated ones and the high-tech ones, but we can also include citizen science, because we already have a lot of citizens that have tools that can be used for data collection, and their knowledge and their active participation and understanding is only to support. So I think we should consider that. I mentioned funding, but like I said, it has to be available and long-term. International collaboration is a must for the collection, integration, and interpretation of data. And this will lead to increased understanding of to secure environmental safety. Again, this has to be done on both sides of the strait, and I know Paul will have a talk on that. But again, it's all interconnected, and I was involved in a exercise a few months ago where the discussion was what will happen to the U.S. if there's an accident in Russian waters, and of course this is a concern. So we have to acknowledge it, and try to find ways to work together. Alexander mentioned the business plan that has already been developed within the Northern Sea Route. I think a comprehensive, expanded business plan and guidelines based on environmental values and sound knowledge is a key for the successful utilization of the Northern Sea Route in a global context. Because as I tried to mention before, the business case of the Northern Sea Route is not clear to many of the operators. There are problems for operators related to insurance costs. I've been involved in quite many shipping conferences in the past years, and at least the small and medium business operators don't see the value in using the Northern Sea Route yet. But I am convinced that it's possible to change this, but it has to be done from, in a way, top down, bottom up approach. So like the vice director of Costco Shipping said to me in a discussion, the decision has to come from above. And I think that's very true. But if so, it has to be based, again, on a good business plan and guidelines. So in a way, a roadmap to the successful utilization. So I'll stop there, but thank you very much. And I have enjoyed this conversation very much.
Thank you, Father. Thank you very much for your work. And again, the Arctic portal is one of the key player in the data sharing in the Arctic, and of course, providing for a good cooperation, which is super important for the area such as the Arctic. So with that, let's move to other aspects of data processing. And I like to ask Alexei to share with us the recent developments related to using the remote sensing technique, but also developing the digital platforms for the Arctic.
Thank you so much, Alexander. To complement your report, extensive report on the Northern Sea Route prospects and its current and future development, I'd like to stress on some aspects of digital transformation of Arctic shipping. Basically, my report is devoted to some digital services that are already available for shipping companies, for shippers, and all interested parties, including scientific and state organizations that operate in the Arctic seas. Actually, our center considers the Northern Sea Route as a huge, complex task. And there are just some of the tasks that I've indicated here, but I'll focus more on monitoring of the environmental biodiversity situation today with the use of digital technologies. But the spectrum of tasks and plans that need to be implemented is huge. And as Alexander said, there are several strategic documents that determine the Arctic development. But of course, there are much more those. In order to store, analyze, and share data on Arctic developments, our center has designed a digital platform called Sloika. It's basically in Russian, a plenty of layers that contain diverse information on the state of environment, biodiversity, climate, and other issues related to environmentally safe shipping. And I'll focus more on those services that are available already now. This is basically the interface of our digital platform. It's basically in Russian, but there are many pictograms, images that allow to understand what's happening there for both Russian clients and foreigners. Most services are based on satellite monitoring tools. Basically, we use both European satellite images from Sentinel-1 and Indian and Chinese images, and we hope also to use Russian images in the near future. As for the ecological monitoring services, I would say a couple of words about what we've already introduced for our customer Rosatom in the recent years. Those services are related to shipping intensity control. Basically, this is the calculation of vessels crossing marine sectors in the Arctic, identification of oil pollution and its sources. I'll talk more about it later, and control of protected areas regimes and transit in the Arctic, having in mind ecologically important marine areas. Pollution is one of major issues if we talk about Arctic marine operations. And if we identify oil spills in the Arctic, it's necessary to act fast. Otherwise, there is a high risk that the consequences will not be mitigated at all. And for this reason, we use the following scheme of work. First, we identify oil spill detection, oil spills based on satellites, satellite images, SAR or optical satellites. Then our team for hydrometeorological modeling forecasts surface currents. And then we model oil spill drifts, and can identify with a high probability the source of pollution. It can either be vessel or oil platform, having in mind the intensity of shipping in the Arctic now. We can be very much sure that this oil platform or that vessel is actually the source of pollution. And then all this data can be stored and seen and shared with our clients via email or via messengers, actually. And all this data stored on the digital platform. Of course, in order to identify the source of pollution, we need to understand where vessels are, and for that we need AIS data that we regularly get from the responsible bodies. Of course, we analyze also CO2 emissions and calculate them based on fuel consumption. This interface is quite clear. We can either choose a vessel that is a potential source of CO2 emissions, or choose the area in the Arctic and see whether carbon footprint here is large within normal conditions. This service is quite new. We can identify whether a vessel exceeds recommended vessel speeds in certain areas that are characterized by some marine mammals populations. But for that, we still need to go a long way because there is no regulation in Russia so far that constrains the speed of vessels in the Arctic, or somehow makes it necessary for a vessel to avoid some areas or some sectors in the Northern Sea route. And a couple of more words about marine mammals. Of course, we can use neural networks, artificial intelligence to teach our neural network to identify some kinds of marine mammals. In this case, we see walruses in remote Arctic areas. And if we have a conversation with the representatives of the marine industry in the Arctic and ask them, what is the main problem for your shipping operations, and what is needed to make the Northern Sea route sustainable and environmentally safe and just safe and secure? And they say, we lack ice charts. Basically, it is the demand of shippers to get ice charts in time and in high resolution. And our team also can provide such data. Then our experts analyze what they actually mean, and these data can be sent to all interested parties. This is also related to ice drift, because the climate change and other factors naturally have an impact on ice drift, especially during summer, because before we had window of navigation limited to maximum 2 months. Now it can be much wider. And that is why it's necessary to understand whether shippers can plan their operations via Arctic routes. As for the system, this is quite comprehensive, because system considers both atmospheric components, waves, currents, and ice, and allows to make a forecast for 75 to 120 hours for clients. And if we compare this model with other available solutions in the market, as it relates to the Arctic and the Far East, we can see that both spatial and temporal resolution, coverage, and comprehensiveness are superior to those models that exist in other countries, including USA, Canada, Norway, and France. And concluding my presentation, just a couple of words about the routing. Actually, adaptive routing is one of the most prospective areas where we develop our digital services, because using digital technology, we can actually apply algorithms that have in mind environmental factors, fuel consumptions, ice and hydrometeorological conditions in complex. And that allows to construct those routes that lead to the reduction of CO2 emissions, have lower environmental impacts on Arctic marine ecosystems, and allow to transport cargo from point A to point B faster. And that is an advantage for shippers. That is why we believe that the Northern Sea route offers great opportunities for those companies that believe in Arctic shipping and understand that it is a long way. We will not get the results that everybody wants today or tomorrow. We need to wait, but we need to work towards this goal. And I thank all the participants of today's conversation that they share this idea. Thank you.
Спасибо, Alexei. Thanks a lot for your presentation again. The development of those new methods is extremely important and can help very often in a real time. So with that, I'd like to move to our colleague from Alaska, Paul. I hope, Paul, you are with us.
Yes,
Paul.
I am.
Yeah. Who is one of those who actually ensure on a daily or maybe on an hour basis the safety of shipping operations in the very rough waters of Beaufort Sea and Bering Sea. Paul, we will be happy to hear your experience and sharing with us your approaches.
Can you put up my presentation, please? The first slide is this is Marco Polo in the 21st century, which is basically the situation that we're in right now, looking at establishing a new sea route. I've shown here just a combination of combining it with the Great Circle shipping route. Next slide, please. So, you know, this is some of the data. This is from 2023, and you can see it's all color-coded by which type of vessels they are. And what we saw during 23 was about over 80% of the cargo was petroleum products. So again, this is very much highlights the issue that we need to have the best prevention measures that we can for safe shipping. Next slide, please. So we see that the Arctic traffic is increasing, and even 24 quite a bit more, including some shipping, more container shipping, which every world trade route started out as a bulk trading route, but to become a true world trading route, we have to get to container operations. Next slide, please. So this is what you know, we see on a regular basis of all the time of all the shipping, and up around the Aleutian Islands there, you can see the Great Circle route and the amount of traffic that's there from North America to Asia. Next slide, please. And again, this is just one day on the Great Circle route, so there's a potential of connecting with these vessels as well. The idea is that ice-breaking vessels should really only be used mainly in the ice. They're not very efficient when you get into open water. And if we can do some connections to a transshipment hub, that may be a more efficient operation. And we're proposing Adak, Alaska, and on the Russian side, the most probable port is Petropavlovsk-Kamchatsky. Next slide, please. And this is a picture of Adak, of the port. It was a naval base. It's now been turned over to the indigenous people, and this would be our proposal for a transshipment hub. Next slide, please. So, of course, this is the Bering Strait, you know, our shared environment. You know, the water, you don't see any lines there. The water doesn't care. The marine mammals don't care, and the fish don't care. We have a responsibility to jointly manage this. And of course, it's very frustrating for us now, the sanctions that have been put in place to keep us from being able to work together on fisheries research and management, all the Arctic Council deliberations, and hopefully that'll be resolved soon, especially because we have had a new election in the United States, and we hope that makes a difference. Next slide, please. So here's our concern. Here's the primary flow rates of, you know, in the Beaufort Sea and Chukchi Sea. And we see that if we were to have an incident, an oil spill, for example, in there, these currents would carry that pollution throughout the entire Arctic. And of course, if it was trapped in ice, that'd even be worse. that would continue to release for years to come. Next slide, please. So this is our concern right now. We're seeing a tremendous amount of crude oil being shipped through. Some of them aren't really even on ice-class vessels. And we understand why it's happening. It's because of European sanctions on Russian oil. And so it's being shipped to India, China, Japan. So, you know, hopefully when this situation is resolved, we'll get back to a more normal transportation system. But you know, while we understand why it's happening, it also tells us why we need to do as much as we can to try to have safe shipping. Next slide, please. So this is what we're calling Arctic Watch, and we received a grant from the U.S. government of $2 million to put this system together on top of what we were already doing. Next slide, please. So for those that may not have been on the ocean, this is what an AIS, automated identification system, looks like. You have an antenna that's a transmitter, transmitting the location of the vessel every 6 seconds, and we track it by a GPS. Now you also have the Russian system GLONASS. GPS is accurate to 3 meters, and GLONASS is a little more accurate to 2 meters, but you know, 1 meter doesn't make that much difference in the ocean. But you also see the display there, and that's very important because we made some real advancements in sending navigation data and environmental data, weather data directly to the vessel via the AIS display. Next slide, please. So what we're doing is we monitor 24 hours a day, 7 days a week. Our workers there are monitoring this. What they're looking for is they see the regular shipping operations. If you see something that's different, like the vessel, we've got an automatic alarm. The vessel slows down to 3 knots. We know that there's something happening. So we call that vessel and say, what's the story? You're down to 3 knots. Do you have a problem? They might say, no, we're just reballasting. We're okay, but thank you. Or if they've got a problem, we get an early notification. Then we can look for the next nearest vessel that's there that can help respond to them. It might not even be an official government vessel or a tugboat. We've had even where a fishing boat was able to grab onto a big fish processor and tow it just away enough so that it didn't hit the land. Later on, a tugboat came and rescued it. But, you know, we call this a vessel of opportunity. Regulatory compliance, I was interested to hear what you were saying about tracking this. We also get this. Someone finds an oil slick out there. They ask us who was there at that time. We tell them who the vessel was. They go to that vessel and take a sample of either the oil or the bilge water or something like that from that vessel, and they're able to prove that that vessel was the one that created that pollution. And data analysis, we store every vessel track that we have had for the last 25 years. So we're able to go back. If there's an incident, what happened? You know, how can we prevent this from happening in the future? Next slide, please. So we're able to send to the vessel navigation aids, and in the ice, of course, you can't put a traditional buoy, and so we're digitally to the vessel, so it looked just like, you know, red and green buoys like you would normally have. We're also able to geofence. We're able to go out there and, like, we geofence all our fiber optic cables so that, or pipelines, so the vessel knows don't drop your anchor there. We're also transmitting real-time, you know, resource management data. If we've got a lot of walruses come on land at one time, then we put a geofence around and say, don't go too near. You'll stampede those animals and a lot of them will die. Or if we've got, like, let's say, Eskimo whaling going on, we can say, proceed with caution. You've got whaling in that area. And then once that risk is gone, then we remove that notification to the vessel. Next slide, please. So we've got laws in our countries that, you know, if you've got a vessel in your waters, that has to be responded to by a vessel of your country. We're hoping that we can make an arrangement that that no matter which country it's from, if we've got a vessel in distress, it needs to be that whoever has the vessel that's capable of doing that can automatically be told to come in and respond to that. And we're calling this Uber for icebreakers. And these are the Chinese icebreakers, for instance, very nice vessels. These are the Sui Long 1 and 2, but this is important that we in advance have this agreement that whoever is the most able to respond can be the first one to respond. Next slide, please. So these are all of our sites. We've got terrestrial sites, about 150 of them, but we also use satellite data. Beyond this, we've got real-time weather, ice data, hazards to navigation, and notices to mariners. And so these are on all of our sites. Next slide, please. And again, this is all environmental that we're data we can do. We do ice reports. We put in sensors for current. We can tell the vessel what current there are if they're in a restricted area, because that'll have that real-time weather for data. It helps them, avoid a problem with shipping. So next slide, please. So we are proposing to do that jointly with our Russian partners and have some kind of an agreement that we could jointly monitor this and improve the safety in these areas and identify some communication protocols between us so that we can work together and provide the maximum level of safety on the Northern Sea route. And we've been in those discussions, and we'll see. We know that there are administrative actions that need to be taken by people, Northern Sea Route Administration, the Ministry of Transportation. But as our organization and with Russia, we can do this on a bilateral agreement. Now, the International Maritime Organization could also require this cooperation, and that probably would be a good idea to put that forward. And this is not something new. It's basically the same system that Russia and Norway now have with the Norwegian Coastal Administration for oil tankers and shipments from the joint oil development zone north of Russia and Norway. So we're hopeful that this can be accomplished in the near future. And that's my presentation. You have my contact information there. If you have any questions, I'd be glad to answer them. Thank you.
Thank you very much, Paul, and thanks a lot for this very important job, but also for highlighting, right, once again, the importance of cooperation. Even in difficult times, we definitely need to go this way. So,
excuse me, I just have to say, I have to catch my flight, so I'm going to have to leave now and sign out. But I thank you for the opportunity to participate here, and good luck to all of you.
Thank you very much, Paul, and safe travel home. So with that, let's move again to science. And I like to ask Yelena to share with us the experience of doing science in the Arctic Ocean, on the Arctic shelf, and how, from your perspective, that may help actually the environmental safety in the Arctic.
Yeah, thank you, Alexander. So yeah, just first of all, I feeling myself like I'm in the Arctic pavilion because I'm just freezing a bit. So I think that's that's a good place for the Arctic discussion. So yes, also I would like to refer to your words in the beginning that finally we have the distinct Arctic pavilion here at COP. That means a lot because I would like to focus on the climate prospect of the Arctic, not only environmental monitoring, but which is also very, very important for the Northern Sea Road, but climate option, like the climate points is also very, very important. So, well, I think it's not the audience where we should explain why the Arctic is important, but still, so the Arctic is warming, as you know, almost 4 times faster, rapidly warming than the other planet. And so we see this rapidly growing, rapidly increasing the temperature in the Arctic. So And this is the effect which is called Arctic amplification, as you all know, I think. And what does it mean for us? That means that this simplification gives us lots of positive and negative feedbacks to studies. So it gives us so many ways and so many areas of research where we should be focused on. So perhaps when we just perhaps some of them, but talking about the climate aspect, climate warming consequences, of course, we are associating them with the carbon cycle. So you see this perfect picture, which is reflecting the processes which are now happening in the Arctic. All you know, we are talking about the Northern Sea Road, we are talking about infrastructure so actively, but this is about the climate, because we see that carbon is that the permafrost onshore and subsea permafrost is being degraded, and also it's being unlocked from those deposits which have been considered as very, very stable for dozens of years, and for hundreds of and thousands even of years. So that's why we are having the, like the processes are very rapidly changing. So, and this is the basic topics which are should be focused on, should be studied very much in detail. So some of them are degradation of the permafrost of the subsea, as I said, and the onshore permafrost, and the emission of the greenhouse gases, not only CO2, but the I think the most important, more important in this case is CH4, which with the methane, which I will be talking about later. And then we also have the effect of the acidification of waters, because I think some of you know that the acidification is changing the environmental state of the seas, and like the causes, the reasons for why the acidification occurs, they are different in the eastern Arctic region. They are heavily dependent on this carbon which flows from this degraded permafrost. And so we are having this one another positive and negative feedbacks happening. So we are having the change in biogeochemical regimes of the seas. We are having this increase in heterogeneous carbon flow going into the shelf. And all this gives us so many challenges to study the background, the background of the Northern Sea Road areas, of the water masses of the secretary. So this is the pictures of our basic, the research areas of our team. I would like to focus to underline that I'm not talking only from the Sirius University of Science and Technology, of course, because as you said, the Sirius University is one of the youngest universities in Russia. So the Climate Center, which I'm representing is the younger than university else just in 1 year. And of course, these results are the results of many, many years of research of the huge group, which is led by our Russian leading scientists, Professor Igor Semiletov and Professor Natalia Shakhov. So I will be all the time referring to their publications and papers, which are very actually highly contributing papers in this Arctic science. Well, and you see these pictures and you see this polygons, which I underlined, they're the polygons where the shallow hydrides deposits are focused on. And we see the East Siberian Arctic shelf, which the Northern Sea Road goes through. This is East Siberian Sea, Laptev Sea, and Chukchi Sea. The western part of the Chukchi Sea is underlined by the subsea permafrost. And the hydrides in there, which have been considered, as I said, as stable. And those hydrides contain just a huge amount of methane locked there and being unlocked now. And well, you see the pictures of the methane seeps, which we are just looking at in our expeditions. So going through the Northern Sea Road, I think that also the ships could see them, because this is like the methane seeps. The gas flows from the bottom, and this is the methane, which could be of different genesis, of different sources. But basically, the most I don't know. I think the word dangerous is quite critical, so very extreme. But I think the most prominent source, we think that the most prominent source of those gases, of this methane, is destabilizing hydrates from the subsea permafrost. And you know that I will show some slides about the contribution of this methane into the atmosphere. So this is just the basic about the research. So how we get the data. We talk much about the data. So about the digital platforms, about the gathering this data. And this is how we gather this data this year. So this is our road, you see along the coast of the East Siberia. So in the sampling map. So, and I would like also to underline the importance of the international cooperation in this way, of course, and to exchanging this data, because this is like the, very, very crucial pieces of knowledge, which should be, of course, treated together and discussed together, because that means that we install in the Arctic monitoring system, but we should know how it works as a background, as a natural process are going there. So that's our guys from the expedition, just coming back from 45 days of the gathering this data for this digital platform. So these are our heroes. And this, I would like to focus on those directions which we now are developing in serious labs and the partnership labs. Of course, this is the study of greenhouse gases flows, as I show the methane seeps pictures. Then we also know that this hydrates also represents and the geological hazards, the geological risks, of course, because this can be destroyed and degraded. And so what's going on then? Of course, we study these carbon cycle processes. Like from rivers into the shelves, and we should know how this carbon behaves, because it comes from the earth, from the continental part, and it could be mineralized, and it could be turned to CO2, it could be just buried in the sediments and never again happen in the atmosphere. But we should understand which part of this carbon goes into the active cycle and which part can affect the climate system. And this I will briefly introduce the key results. The solar results are published, and you can see the papers where they are published. Just from the 10 years, 15 years, but they are very relevant today. Not just relevant. These numbers, these calculations are just increasing and increasing. I mean, the fluxes and the concentrations and the numbers of seeps that we are detecting. So I think the crucial complex, our collaborative studies are crucially needed here, of course. So you see this East Siberian Arctic shelf. The key results, of course, is the East Siberian Arctic shelf serves as the significant source of methane to the atmosphere. So because of these hydrates, because of this carbon cycle, which is changing rapidly. So in the we see surface concentrations of methane over the East Siberian Arctic shelf. We see that this is the highest surface concentrations in the Eurasian marginal seas and the overall over the entire northern hemisphere. So that was the baseline of the hypothesis. So why they are the highest? So we started to look for the reason why they're highest, and then went to the subsea permafrost then. So you see this, this very high peaks of these plots. You see the increasing concentrations of methane over those areas. So that's the special areas over the large shelf, and these areas begin to extend over the years. So well, another very, very much important result is that the subsea permafrost now is in the transition stage, which is where at that time the onshore permafrost is quite being stable. So we see that this permafrost time to be degraded, and the gas front also, you see the key result, the next key result. So the gas front is moving upward with a rate up to 7 meters a year. So this is actually just a huge rate, as you see. So that means that the rate of this degradation, of this destabilization of hydrates and releasing of methane is increasing. So, and it's about the vertical rates of the subsea permafrost degradation. How did we calculate this? How did we understand this? We re-drilled the boreholes, the wells, from those which were drilled in 1982, 83. And we re-drilled them in 2013 and see that the rate of the movement of the ice-bounded permafrost stable layer is of around 14 centimeter per year, which is just almost the order higher than is expected to be. And so I'm coming to the end of my talk here to leave some for a discussion, but the annual flux from the East Siberian Sea, they are depending on the subsea permafrost state and the onshore permafrost state. So, and that's the point that should be that should be entirely studied all together and studied in details, of course, because that's the, as I said before, that's the baseline for the monitoring system. So before we monitor pollutions, before we monitor climate effect, we should understand how it works as itself, how it works itself. So thank you for this discussion. Yes. So I think that's very fruitful and very needed. Yeah. Thank you.
Thank you very much, Elena. Thanks a lot also to bringing our discussion closer to the COP29, closer to climate. And we're also very much happy to see that there is now a new strong institution so much engaged into the Arctic research. So colleagues, let's move to our other speaker, Professor Nandan. I hope you are with us. Yes, great to see you again. Sorry that it's only online. We will be happy to see you here in person. And we like to hear on your experiences working in the Arctic. India became one of the leaders in the Arctic science now. And I also like to hear how you see the linkages to the discussion during this COP. Floor is yours.
Thank you, Alexander. Thank you so much. And so happy to be in the Northern Sea Forum Arctic Pavilion. So very nice to see Elena, Vladimir, and all our colleagues who are participating in this session. I think it's audible from my side. It's audible? Can you hear me?
Yes, we can hear you.
Yes, thank you. Okay, now I think I've just seen the very significant and very valuable presentations prior to mine. They were all focused on different areas of Arctic, the shipping, the technological innovation, the permafrost, the climate change, the blue carbon changes, what is happening in the Arctic. But India has been in the Arctic research in the Neolson for over from 2008 onwards. It's over 2 decades, and I'm part of this endeavor. And we have been participating in the meteorological, the oceanographic, the climate, the bottom, the benthic, the planktonic, the carbon partitioning in along the food web, and all these have been very strong. And one of the models we have been working on is the fjords of the Arctic. And the fjords of the Arctic are very good examples for the climate change and how it's going to have an effect on the global climate change, preferably, specifically, because we know that warming and Arctic sea ice is shrinking. I mean, it has shrunk to about 20 or maybe 15 centimeters. It has just come down from 60 to 80 centimeters. So over the years, when we are visiting, we see this change. It's very glaring. But today, what I'm going to present to you is I'm not going to very specifically speak much on science of our research or what is happening in the Arctic. I will just now focus on the significance of COP29, which is very much, and the Paris Declaration, which is very as a benchmark, and the sustainability aspect for taking us forward to the management of the North and the scientifically management so that it will be eco-friendly and the future generations for the Northern Sea route. Let us go, because this is a little bit of basics. We all know that the Northern Sea route runs through the Arctic, and this has been well explained to by the speakers earlier. And it's very important because it spans along 5,600 kilometers, passes through, and very important development, because we know that the Northern Sea route, if you look along the Petersburg and the Vladivostok, you see how much of distance has to be covered along the Suez Canal. So this definitely shortens the shipping time along the Europe and Asia, and potentially reducing the transit times and the coast. It's definitely one of the significant developments. But over and above, we know that what are the major changes in the context of the global climate change. Comparison, if you make a comparison, I've made a comparison on the route as well as the distance. And if you look at the perspective of the global climate change, it reduces, other than reducing the time and the shorter by 40%. Also, the important, very, very important aspect, reduces almost 20 to 30% of our per voyage of carbon dioxide emissions. This is a significant outcome for the NSR. And my friends from the LMSU, they have been working on these aspects also, how to reduce, how to look at the regular monitoring. These are very, very potential aspects which can be considered under these the COP29 deliberations. Seasonality is also very, very important. We have infrastructure, several ports, and all these governed by the Polar Code as well as the Russian laws of environmental protection. See, the economic potential, if you compare with the Suez Canal road, is also potentially. These are basic knowledge, but overall, if you look at the global warming potential impact, it accelerates the Arctic sea ice melt, but offers emission reductions per voyage. But if you look at the Suez Canal, the other route indirectly contributes to warming and the higher emission routes. But if you look at the current shipping and the current shipping pattern and current shipping and the increased traffic is a major issue, which is also very important. And if you look at the increased traffic because of climate impact of climate impact due to reduction in summer ice cover, and also this is increased navigability of the NSR, making it inaccessible for a longer period each year. And rising of shipping activity along the NSR has been a noticeable uptick in the traffic over the years. Also, the key players, if you look other than Russia, you should look at the global south. That is also very important because they have been also invested heavily. And even though these countries have heavily invested on the infrastructure as well as the especially on the nuclear icebreakers, which we have seen, our friend Paul has also showed that, and the improved port facilities. And the types of cargo is also changing. Other than the natural resources, the consumer goods and the specialized equipment also, if you see. And here, if you look at the various the aspects, if you see, if you look at the increased over the years, 2010, 13, 2019, you can see the maximum NSR, the Northern Sea route has been used by countries like Russia, China, Germany. But please understand, this route is going to be opened up and it's going to be a global institution for definitely the global south. The global south is also something we have to take care. This is very, very important. Now, if you look at the seasonal usage, the seasonal usage is another very important aspect. The primary shipping route, and it is also the North NSR makes the shipping route through the warmer months, during the summer and autumn months, where ice coverage is minimal. So this allows easier access without continuous icebreaker assistance. Also, navigational support to be enhanced. Maybe the icebreaker support for safe passage. Year-round potential is also very, very important because the icebreakers, which we have seen earlier, has limited winter navigation, allowing specialized vessels to operate. So these are some things we have to look at, other than the large fund requirement, the funds and the monetary support we need to have, especially the global climate funds, which has to pump in, which has to be put in for the sustainability. And especially in the harsh conditions, specialized vessels, ice class vessels have to be looked to. Drivers of interest will be the cost and tax savings, time savings, tax cuts. NSR is also very important because it's reducing the transit timing and the fuel costs as compared to traditional routes like the Suez Canal. Rising commercial interest definitely is going to have global demand in the Arctic resources, other than the European EU countries, Russia, and other America and other nations. The global South looks forward to this internationally very, very important area of shipping routes. If you look at the challenges to sustainable shipping, which is linked to the COP29 or our Paris Declaration, we have unpredictable weather conditions. I see the meteorology and the atmospheric conditions are shifting, as my friend Alexander put it at the very opening remarks. Yes, the vagaries of the teleconnections with the tropical and the temperate regions, because ocean is continuous. The global ocean is in circulation. You see, it's very difficult to predict. And every day, if you look at, today what you see is not different from the Arctic temperature and the Arctic weather and the climate and the storm, which is changing. So the shift is sudden, especially with the strong winds and freezing temperatures, and also several blizzards and hazards, which is definitely knocking at your doors. The ice thickness and foam, yes, flows of multi-year ice you can see, and the thickness of the ice is also changing. The seasonal accessibility to NSR is very, very important because of the navigable for a few months. That is also very, very critical, because this all affects possibly our sustainability. The sustainability is a very important. That's why I said, if you look at 16, 17, 18, and 19, if you look at the number of vessels and the number of voyages, it's increasing, especially August, September, October period. These are all to be streamlined when you look at the sustainability part. That's very important to that. But the lack of infrastructure is another important matter of concern. If you look at the lack of infrastructure, which is all infrastructure, the facilities, and upgrading the digitalization, the technology is all part of the greater global challenge, And limited port facilities, you have established ports in NSR, and it is very challenging to support shipping operations. Similarly, the scarcity of refueling and resupply stations, and how sustainability it is going to house sustainable low emission fuels. Yes, this is something which we have to seriously think, which are very scarce along the NSR. The lack of refueling infrastructure facilities limits the ability of ships to use eco-friendly fuels, forcing many ships to largely depend on the heavy fuel of HFO and high impact environmental impact. Limited waste management facilities, poor waste management facilities, these have also to be looked at the larger context. When you look at the navigation safety matters, if you look at the insufficient satellite coverage, the Arctic, you can see the precise navigational challenges. Yes, my friend who has presented previously has said he is looking at the new challenges and looking into new technological changes, which is going to be more reliable and for communication and positioning of the vessels, and also vulnerable to the navigation errors and accidents. This is something which has to be seriously taken care in our future goals. Dynamic ice conditions, ice conditions are highly unpredictable. Even though we measure the sea ice today, it changes within a few weeks or months. So the unpredictability because of changes in the warming conditions and the changes in the carbon content is going to really have a negative impact on the ice conditions. So the obsolete and inadequate mapping is another. Accurate maps, it's a safe navigation is very, very important. Inadequate mapping makes it difficult for vessels to navigate. And also, it increases the risk of grounding and oscillate the collisions of the ice. So we need to have emergency responses. And this emergency responses is something which has to be taken care of in the NSR, where the remoteness of NSR, where we have seen that it is far populated and minimal emergency support. Similarly, extreme weather challenges, especially Arctic, I already highlighted the extreme volatile weather conditions, which make emergency operations as well as hazardous and delays in response efforts. High winds and poor visibility, freezing conditions, and also limit effectiveness for rescue and cleanup. Limited search and rescue. Yes, SAR resources also. Without SAR capabilities, any emergency poses greater risk. So the risk aspect, disaster management, all these have to be taken care because it's a climate change and climate modulations which are happening have to be in a global, larger perspective. The difficult cleanup situation is also because how to clean up the oil spills and other pollutants from these areas is very serious. Now, if you look at the ecological and biodiversity impacts, specifically shipping at NSR, this is largely studied. My friend Alana has just highlighted the biodiversity aspects, carbon. And here you can see, and one of the excellent work which has been done for the LMSU is seen the biodiversity monitoring ship, because these can affect the disruption in these ecosystems. Studying the changes in species composition very specifically has to be done to study this impact. It's definitely the Cochin University of Science and Technology, as well as the Indian different research institutions who are part of the Arctic program are deeply involved in different monitoring along the food web and different dynamics and its feeding cycle, breeding cycle, the carbon inputs in different sectors of the food web. All these are studies which have been largely done, and it has been discussed in many times in this different forums as part of the NSR. Now, habitat disturbance is a major issue affecting the marine ecosystems. Pollution studies, especially to oil spills, is seriously affecting not only the Arctic and nearby areas. The ballast water discharge and the ship emissions, yes, as affecting marine life has been significant. Greenhouse emissions, definitely, which is highlighted, they seriously impact and release because of the enhanced carbon dioxide, and especially in the more ships coming to the Arctic. Cumulative carbon dioxide emissions, global warming potential may increase, accelerate regional warming, threatening the stability of the sea ice. Of course, the disturbance to marine mammals like whales, seals, and walruses, and all definitely the sound which has to be taken care for communication, navigation, and hunting. Yes, definitely the invasive species. The invasive species is another important area which has to be taken care of, because several ships are going to come into the picture, and invasive species through ballast water and the hull fouling is very, very serious. Yes, blue carbon and climate change synergy has to develop, because warming temperatures, thinning of sea ice, and also shipping-induced disturbances are going to be collective. So you need to have a link up of blue carbon linkage to these studies. Food web dynamics, and that helps in the disruptions in trophic level, and this, even though amplification, the Arctic amplification, along with amplification, the cascading effect along the bottom-up and the top-down phenomenon has to be looked into a very specific scale in each food web along different organisms' life cycle. Impact on fish and fisheries is serious, acoustic, especially acoustic cues for breeding and foraging. Migratory path disruptions. Yes, this is very, very serious, because it's going to affect the breeding and feeding behavior, because Arctic noise disturbances, these studies are well established in many global oceans. So now here also, once the increasing shipping activities or other navigational activities definitely is going to affect the seasonal migration and the reproductive cycle. So I would also look at the excellent work that has been being done at the ecological changes and the data gaps in the NSR, because the NSR has been doing excellent work in this area, especially microbes, plankton. I have been gone through its excellent impacts on benthic communities, carbon storage, and filling up those gaps. Filling up those knowledge gaps is critical, because we need to look at understanding the mitigating the NSR environmental footprint. So we need to look at case studies for recent voyages, and also analyzing long-term data sets and trends to get valuable insights, because this is going to have a definite knowledge for a global climate impact, because you need to have long-term data sets, and this will solve our challenges and success to the changes in the NSR. Comparing the historical biodiversity and environmental assessments at an international and regional Arctic agencies, we have seen the global Arctic data. There are several agencies which are looking into this, and we can look at the current findings and can reveal critical trends and guiding sustainable development for conservation efforts of the NSR. So for the sustainable solutions to the pollution, that is also very important. Sustainable solutions to pollution mitigation, reduction and minimizing the environmental impact of NSR is also very, very important, because you need to have a pathway for transition to cleaner fuels. Liquefied natural gas should be there, especially as per IMO's MARPOL and declaration, hydrogen and ammonia, as far as the fuel is concerned. Operational streamlining has to come, especially slow steaming, optimized navigation, waste management also should be in place. Enhanced monitoring and response have to be in place. Arctic Council initiatives, that's tremendous. That has to go hand in hand with the efforts of the various national and international and regional players who are involved in the NSR development and its reality. If you look at the geopolitical and economic benefits of the sustainable shipping through the NSR, we can see that other than shortened transit time, it is also reducing the shipping costs, global links, trade linkages, economic growth, and for the Arctic nations, definitely it's going to improve. And other than the global south is also going to get great benefit out of this through the ports and logistics development, resource exploration, renewable energy, especially you have to use through low emission fuels like LNG, green hydrogen, fostering them investments in cleaner green energy technology and the economic benefits and job opportunities. And if you look at the larger context, I'm coming to the last part of my talk, just in a couple of one. If you look at the sustainable shipping and the climate change issues, we look at that. If you look at the sustainable NSR, shipping is significantly benefit climate change issues by addressing key environmental concerns and promoting low impact economic activities. Reduction in carbon emissions, I've highlighted it's going to reduce from the voyages, it's going to reduce about 30 to 40%. Definitely, these studies have shown that it can reduce low emission footprint trade. This is also going to be greatly benefited. All the data we suggest also suggest from that. Similarly, energy efficient vessels, we can do a lot of research, a lot of activities, a lot of enhancements. You can bring in world partners into the synergy of these energy efficient vessels, reduces carbon footprint. Support to research, definitely, as highlighted by earlier speakers, it's a great opportunity for climate research, especially monitoring ice melt, ocean acidification, and regional weather patterns. Definitely, the teleconnections are very, very important. And but over and above, the sustainable practice in shipping has to be taken care. I highlighted the green fuel, the dual engine, yes, dual fuel engines, the LNG, the biofuel, synthetic fuel, reduce green gases and the emissions into that. Green fuel benefits the NSR. We have to think about possibilities. What is the future for NSR with green fuel? What way we will be able to compliance to the Polar Code? Because IMO Polar Code also stipulates that geopolitical significance. We know that we are losing our biodiversity. Many of our seals, our polar bears, we are many of the extinctions of organisms are happening. So we need to look at the environmental significance, the environmental balance, and look at the geopolitical significance, fostering international collaboration. And also operational practices have to be regulated. And also, which also definitely requires sustainable collaboration with various institutions, biodiversity impact studies, policy integration, increased protection, protected areas. Definitely, we can have marine protected areas in many of those areas of the NSR, which needs to be severely impacted and which needs to be protected. So global collaboration and also the introducing the additional conservation measures, like you have the KMGBF and the COP15 of the Convention on Biodiversity.
Professor Nandan.
Yes.
My apologies, but the next session is coming, and they're asking us to.
Yeah, this is the final.
So
Closing. This is the last. Yeah, I finished. So the COP29 and the global change. So we need to have the larger context of decarbonization in the global shipping routes, and the NSR is critical and reflects the broader time of maritime goals. So shipping decarbonization route, just transition to Arctic communities, and also international funding and partnerships, research and innovations are very, very important. And Arctic policy also, and the creativity, funding, infrastructure, technology, collaboration, and indigenous biodiversity protection are very, very. So the COP29, along with the Paris Declaration, are very, very significant initiatives which has to be taken care, and we have to move forward. Thank you very much for patiently listening. Thank you. I put my objectives in perspective. Thank you.
Thank you, Professor. Thank you very much for this very comprehensive presentation on shipping and different aspects of it. And with that, I'd like to thank all our fantastic speakers present here, but also our colleagues online with us. So please give a round of applause to all our speakers. Thank you very much. And with that, we give the floor to the next session. Thank you.
Thank you all. Take care. Thanks. Bye-bye.